Okay. So it's being recorded, and then I'll send it to you as soon as it uploads after.
Okay, thank you.
Okay, let me share my screen. Okay, so these are from the practice problems. I just pulled a bunch of random ones because like the first, I don't know, the first 20 are all pretty much the exact same thing. So if we have to do more than one, we can, but I just pulled one from there and then a couple of the word problems.
Okay.
So basically, when you're doing this whole chapter is on hypothesis testing. So when you do a hypothesis test, there's some claim being made. So like, let's just say like if I was talking about, I don't know, Skittles, the candy Skittles. I guess they spell it right. And Skittles says that 30% of all Skittles are red. Okay, that's just standard. That's how much they put in each bag. So every time you get a bag, you should have about 30% that are red. But you've been noticing that when you buy Skittles, that there's like barely any red at all. So what you want to do is you conduct an experiment. You take a sample, and you're saying, well, if I've sampled, I don't know, 100 bags, and I've noticed that on average there's 22% are red. Is that good enough for me to say that Skittles is lying, or is it not good enough for me to say that Skittles is lying? Okay, so basically there's some claim being made, and then we're going to use a sample to try and dispute that claim. Okay, and there's some weird rules to remember, like when we word our conclusion, how we word our conclusion, how we word the hypothesis, and all that. It's kind of like an industry standard, but we'll go through a couple together just so you can kind of see how it works. So the first couple, they don't really give you any kind of context. They just give you some generic null hypothesis and an alternative hypothesis. So this says you wish to test the following alternative hypothesis at a significance level of 0.10. So that's how good we have to be. We have to be 90% confident, which means 10% quote unquote not confident. So their claim is whatever we're talking about is the average is 70.1. Okay, we can say whatever you want about this, but whatever they're saying is the average of something is 70.1. We want to try and show that the average is actually larger than that. So our alternative is going to be mu is larger than 70.1. Okay, you could say maybe Monaco says the average graduating grade for all math students is 70.1, and we think it's higher because everyone in our class is getting really good grades. So that's the kind of thing you can do. Okay, they claim it's 70.1, we want to show it's larger. So we take a sample, we have a, essentially the population is already distributed, and we know the standard deviation. So we have sigma. So just like last chapter, if we know sigma, that's going to imply a z-test, just like we did with z-intervals. And if we don't know sigma, if we just have s, that's going to imply a t-test, just like before. Okay, so our sample mean is 73.1, and our sample size is 73. So we're going to go back to the similar menu. We're going to go to the stat menu. Stat. Tests. We're going to do a z-test because we have sigma. We're going to input our stats. So now this is the null hypothesis. This is going to be 70.1, what they claim. And you'll notice that in all these problems, the null is always going to be mu is equal to something. You'll never see like H null be mu is less than or equal to something. That doesn't happen. So it always has to be equal with the null. So when you get to like multiple choice problems, I'll show you one in a second. Whenever one doesn't have an equal sign here, you know automatically it's going to be wrong.
Okay.
The null mean is 70.1. Our sigma is 8.4. X bar is 73.1. Our sample size is 73. And now we're going to pick, we want to prove that our mu is greater than the null mu. So we'll use that. And we're going to calculate. Okay, we get a bunch of stuff. The first thing we get is the test statistic. That's going to be the z-score. So we get 3.051. And then our p-value is going to be 0.0011. So basically we're saying that if this is true, The chance of me getting a sample with an average of 73.1 from a sample size of 73 is 0.11%. So it's so improbable that we get this result that this must not be true. Does that make sense?
Yeah.
Like if I said, all right, we said 70% of Skittles are brown. I tested 70, whatever, 70, let me, how many bags it was? 73 bags. I noticed it's 73% were brown. That's so unlikely that this has to be false. So when your p-value, whenever you get your p-value, you always want to compare it to alpha. So we always say, is p greater than or less than alpha? In this case, p is less than alpha. And here's an easy way to remember. You can say, if p is low, we reject H. So P is lower than alpha, so we're going to reject the null hypothesis. We're going to reject this. Okay? So you'll see that, well, here we go. P is less than or equal to alpha. And then we have, there's three options here. It says you can reject the null, accept the null, or fail to reject the null. Just like, this is one of those weird things in the stat world. We never say we accept the null. That's never going to be the answer. You either reject the null or you fail to reject. Kind of like when someone goes to court, they never say this person was found innocent. They just say guilty or not guilty.
Okay.
They fail to prove guilt, so they can either prove it or not. So we never say, okay, well, this has to be true. We just say, well, based on our sample, we can't show or we can show that this isn't true. Okay. But since our sigma is less than alpha, we're going to reject the null, so we're going to fill that one in. Which basically means that now we can say that this thing, based on our sample, must be true. So this last question of these is usually the trickiest because they just mess up the wording on purpose. But it says, let me move that over here. There is sufficient evidence to warrant the rejection of the claim that the population mean is greater than 70.1. We're not rejecting that claim, we're accepting that. So be that guy. There's not sufficient evidence to warrant the rejection of the claim. No, we're not rejecting the alternative. It has to be, we want to accept the alternative. The sample data support the claim that the population mean is greater than 70.1. That's what we want. We've shown the alternative must be true. So based on our sample, we've shown that it is greater than 70.1. Does that make sense?
Yeah.
Okay. Yeah, this part, whatever questions have these, I think this is the trickiest part, just because English is so, really, they purposely try and make it confusing. So let's just see, we'll look at another one here. So this one, it's a similar idea, except now we're just trying to show that the average is not equal to something. We're not claiming that it's higher or lower. We're just trying to show that it's not equal to the value they're giving us. So the problem, everything's the same, except just want to point out that it says we do not know the standard deviation. Whoops, I want to make that a highlighter. We do not know the population standard deviation. So that means this is going to be a t-test. Back. There we go. Okay, so everything works the same way, except now I'm not going to use a z-test, I'm going to use a t-test. My null mean is 54.2. My x bar from my sample is 48. My standard deviation from my sample is 17.8. And the size of my sample is 32. Now we're just going to, this is called a two-tailed test when we are trying to find it not equal to something. So if it asks for if it's a right-tailed or a left-tailed test, it might ask on some of those questions. If you're trying to prove something is less than, that's a left tail. If you're trying to prove something is greater than, that's a right tail. It's kind of common sense there. Less than is left, more than is right. We want not equal to, so we're going to calculate. So here our test statistic now is going to be negative 2.0009 or 2.001. Negative 2.001. The p-value is 0.0539 or 0.0539. Our alpha here is 0.02. So when we're comparing our p-value and our alpha, p-value is greater than our alpha. 0.05 is greater than 0.02. So the p is not low. So we cannot reject HL. So the p-value is greater than alpha. So that means we failed. So again, it's never going to be accepted. We failed to reject null. Okay? So you can say something like, I don't know, let me look for questions. Question 3, let me go back to the problems here. So there would see there's not enough evidence to show the alternative. So we would say there is sufficient evidence to warrant the rejection of the claim. The population mean is not equal to 54.2. Hold on. There's not sufficient evidence to warrant the rejection of the claim. The population is not equal to 54.2. There's not sufficient sample evidence to support the claim that the population mean is not equal to 54.2. I don't think it's ever going to be these top two. These are just like double negatives and a whole bunch of crap going on. So it's going to be the answer is there's not sufficient evidence to show the alternative. If we were taking this class in person and doing the tests in person, every single answer I would say, you'd always either say that there is sufficient evidence or not sufficient evidence, and then rewrite the alternative. So here we're going to say there is not sufficient evidence to show the population mean is not equal to 54.2. So that's probably your safe bet, okay? I would say stick with that as your answer. Always try to write it in terms of the alternative, okay? Now, the first, I don't know how many questions, but they're all kind of like that. They give you the hypotheses, you just plug it in the calculator and copying the numbers down and comparing alpha and p. For like question 7, it's the same thing, but you have to put all this into your stat list.
Okay.
Use the, you'll go to t-test because we don't know sigma, and you'll use the data command. So you'll put all the data.
Okay.
It's a pain, but I don't know how many there are, but you have to put all these in one column, one list. Okay.
Oh, all right.
But I did copy 24 just to show you the kind of word problems they might ask you. So it says a well-known brokerage firm executive claimed that 70% of investors are currently confident of meeting their investment goals. An XYZ investor optimism survey conducted over a 2-week period found that the sample of 500 people, 65% said they were confident in meeting their goals. Test the claim that the proportion of people who are confident was smaller than 70%, is smaller than 70% at the 0.05 significance level. So I told you the null is always going to be equal to. So if I look through these answers, it's not going to be this guy, not going to be this guy, not going to be this guy, not going to be this guy. It's going to be this or this because it says mu is equal to. But we're trying to show that the confidence level is smaller than 70%. Well, let's see here. That's not, none of these are right then. This is a typo. But these are the exact same thing. Oh no, this is proportion. So it wouldn't be this one. That's not right because it says not equal to. Let me see what the computer says. Because it really should never say greater than or equal to. That is number 24. No, that's not right. Okay, well, I'm going to fix that question because you really should never say greater than or equal to 70%. Absolutely not correct. So they're saying this, that's not right. Okay, so I'll fix that question. But let's just pretend this says equal to and this says less than, all right? So we want H null is P is equal to 70%. And the alternative is going to be P is less than 70%. Okay? So, since we're trying to show something is less than, that's going to be a left-tailed test. All right, so now we're going to plug everything into the calculator. But now we're talking about a proportion. So before, they were about averages, means, mu's. So now we're going to use the same menu stat over to tests. We're not going to use a z-test or a t-test. We're going to use a one proportion z-test. So these are the only 3 we use, z, t, and one prop z-test. Okay? Like that, our null proportion is going to be 0.7. X is the number of people in our sample that had this characteristic. So notice here, they don't give us a number. They give us 65%. Okay? If you plug in 65 here, you're going to be wrong. Because X wants to know, of the 500, how many were confident. So before we actually go into here, we're going to have to figure out what is 65% of 500. So we'll do 500 times 0.65. So this is going to be 325 people. So now we'll go back into that. One property test. 0.7. Of the 500, we have 325 that said they were confident out of a sample of 500 people. And we're trying to show that it's less than the null. So we hit calculate. So we get a test statistic of negative 2.439, or to 3 decimal places will be negative 2.440. The p-value here is 0.0073. And then we're comparing our p-value to our alpha. Which do they give us alpha? Oh yeah, 0.05. So if alpha is 0.05, this is going to be less than alpha. So our p is less than 0.05. So the p is low, we reject HO, so we can reject the null hypothesis. Okay, so we can say something like, based on our sample data, there is sufficient evidence to show that the population proportion of people who are confident is less than 70%. Okay?
Okay.
Does that make sense? That's kind of one of each type. But, yeah.
Okay.
What are the other ones you'd like to see? I mean, any individual questions you have while you're working, you can send me those as well. That's kind of an overview of everything you're going to see. Okay?
All right.
All right, cool. So yeah, I guess for some of these practice problems, so like for number 28, it says test the claim that the proportion of people who own cats is significantly different than 40%. So proportion would be equals 40%, and you're trying to show that it's not 40%. Okay. So the rest of them should make more sense than what we did, but I don't know why that was like that. All right, but you just send me any questions you have besides those. All right.
Okay. Thank you.
No problem. Have a nice day.
You too.
I'll send you this video as soon as it uploads.
Okay.
All right.